Okay, welcome back. So we are at example number 4 in section 12.3. And so we're going to look at how we can find the standard deviation for a frequency distribution, but this one is going to be a grouped frequency distribution. So we're going to have classes that we have to contend with, and how do we get around that? Now, a couple of footnotes. Our intervals are set up to give us nicer results, so that way we don't have really a terrible amount of decimal places. Because if you look at this, we have a problem. This first interval ends at 27.5 and then it starts at 27.5, which is a no-no. That really shouldn't happen in a frequency distribution like this. So we're going to go with it though, so that way you can see the process. So the first thing is how do we navigate through this? What does this really help us? How do we get a value, an X, so that way we can get the ball rolling? And the trick is, I have a column here called midpoints, and that is going to be our X. So midpoints for these intervals. So now you're probably wondering, what do I mean by midpoint? Well, so we're trying to find the middle of this interval. And the easiest way to do it is to average those. Average the smallest and the largest together and see where the middle is. So all you have to do is just add those together and divide by 2. Now, I didn't do it right, because if you do it right, you should get a nice answer. So when you add them, be deliberate. Add them and get the result, and then divide it by 2. In this case, we do get 25. And we can see that 25 does look like it's in the middle of that interval. So 25 is the first midpoint. Now, we can kind of hopefully see the pattern here, but if you're not sure, the trick to getting all those midpoints in a little bit simpler fashion than averaging all the way through is to look at what happens vertically. Remember that class width from section 12.1? You can use that here. So if we see that we're adding 5 all the way down vertically, you can use that same pattern to get all of your midpoints. So much, much faster, right? So there's our midpoints. So those are the numbers that we're going to use to represent the data. It's not the actual data, but it's representations of the data, because we don't know what they are. All we know is that there's 2 numbers in this interval, but we don't know what they are. So we're going to guess that they're somewhere in the middle of that interval. So 25. And in this case, we're representing this interval by the number 30, and we know that there's 41 of them in there, and so on. So we can now proceed just like we did in the previous problem. So remember, the next and first step is to find the mean. So we're going to need X times F. And our frequencies, remember, are our F's. So let's see what we get. So remember, we got to multiply across. So it looks like we got a 50 here. That looks like 1240. And, well, let's make sure I do this right. So, or that's actually not 1240, but 1230. I need a better eraser. So 1230. So 35 times 79, 2765. 40 times 28, 1120. 45 times 15. And the last one I can do. All right, so there's our products. Again, we're starting with step 1, getting that mean. So we have to add up all those numbers, all those products. So 50 plus 1230 plus 2765 plus 1120 plus 675 plus 300 equals 6140. And remember, we need to divide by the sum of the frequencies. So let's clear that. So 2 and 41 better be 43, plus 79, plus 28, plus 15, plus 6, 171. So let's see what we get. $61.40 divided by 171 equals 35.906 and change. So let's round that to 1 decimal place to 35.9. All right, so now we have our mean. So that's step 1. And so now remember step 2 is subtract. So the value minus the mean. So we got 25 minus 35.9. So that looks like a negative 10.9. And we can go from there. So 40 from that. So it looks like 4.1 and 9.1. Now, just double checking that. I think that might be a boo-boo somewhere. Oh, I skipped one, that's why. Thought there was 5 numbers and there's actually 6. So let's make a little bit more room here. 4.1, 9.1, and then 14.1. So we had one more in there I had to squeeze. Okay, so that looks like it should be right now. And so that's step 2. On to step 3. We got to square them. So all those numbers, so 10.9 squared is 118.81. 5.9, 34.81. 0.9.81. 4.1, 1681. 9.1, 8281. And 14.1, 198.81. A lot of 0.81s in there, but that's okay. 9s and 1s, I guess they go together. So there's step 3. Step 4, not quite yet. Remember, we can't add this column up because we haven't accounted for the frequency. So we got to have that extra column. X minus x bar squared times the frequency. So just be careful when you grab those columns. Make sure you're grabbing the right ones and multiplying the right numbers. Very easy to get it confused. So 2 and the 118.81. So 2 times 118.81 equals 237.62. 41 and 34.81. 1,427.21. 0.81 times 79. 63.99. Okay, 28 and 1681. 470. 68. Okay, 15 times 82.81. 12. That 100. Whoops. 42.15. And then the last one, 6 times 198.81. 1192.86. All right, so again, we kind of have a 3A and 3B step when we have a frequency distribution. So, but now we can go to step 4. So again, this was step 2, 3A, and 3B. So step 4 is to add those all up. Now last column, 237.62, 1427.21, 63.99, 470.68, 1242.15, 1192.86. So 4,634.51. Don't clear it. All right. So far, so good, hopefully. 2 more steps. 5 is divide. 5 is divide. So 4634.51 divided by, be careful, make sure you have that n. N is 171, so we're going to divide by 170. So keep it in there. Divide by 170, 27.26, 1823. And then last but not least, step 6. Square root 5.2. 2128.562 and change. So 5.22, but 5.2 works just as well. Again, 1 decimal place for whole number data is all you really need. All right, but follow what the rules say. Follow what the directions say. All right, now before we close, I do want to ask a question. Is this the true standard deviation? Why or why not? So, is that 5.2 the actual standard deviation for this data? The answer is no, it is not. Because remember, we were guessing at what the data was. We didn't know what it was. So it might be accurate, but it might be a little off too. So, but it's going to be close. It will be close. But just keep that in mind. So no, because we approximated the data. Boom. All right, and you can see this should have been on the next page, but that is what we're going to be doing in the next video. So stay tuned for that.